Area under a curve, the definite integral. In physics, we often need to find the area under a function, meaning the area between the function and the x-axis. Previously, we only did this for simple shapes like rectangles and triangles. Integration lets us do that for many more functions. If f of x is continuous on AB, then the area under the curve is the integral of f of x from a to b. Area equals the integral from a to b of f of x dx. The integral represents the net area, meaning all area above the x-axis minus any area below the x-axis. The expression is read as the integral from a to b of f of x dx, or the integral from a to b of f of x with respect to x. Here are some properties of integrals. The integral from b to a of f of x dx equals the negative integral from a to b of f of x dx. So if you switch these numbers here, this becomes negative. Here we have the integral from a to a of f of x dx, and that's 0. So if you have the same number on the top and the bottom here. Here we have a constant multiplied by times the f of x. So we have the integral from a to b of k times f of x dx equals k times the integral. So you can just move this constant out front. Here we have the addition or subtraction of functions. So this is the integral from a to b of f of x plus or minus g of x. You can just separate them into two parts. So you can take the integral of the first function plus or minus the integral of the second function. And finally, we have the integral from a to c of f of x dx equals the integral from a to b plus the integral from b to c, as long as a is less than b is less than c.